In this question, we are asked to express a trigonometric function 2 sine x minus 3 cos x in harmonic form. So specifically the form r times sine x minus alpha, where r is greater than 0 and alpha is strictly between 0 and 90. We are then asked to find the maximum and minimum values of 4 over 2 sine x minus 3 cos x plus 8. And lastly, I haven't decided yet, but lastly I think we will solve the equation 2 sine x minus 3 cos x is equal to I'm going to say 2. Okay, so to start with, we need to write the equation, or the expression, sorry, in harmonic form. So the way I do this is I look at the form they have asked me to express in. So in this case, r sine x minus alpha, it's usually that. And I expand it using the compound angle formula for sine. So we need to remember that sine of a plus or minus b is sine a cos b plus or minus cos a sine b. So here I have x minus alpha. Alpha is positive, r is positive. So I can just use the minus form. Okay, so I can say I have r sine, I can basically say I've got r sine x cos alpha minus cos x sine alpha. And I can expand times everything by the r, so I have r sine x cos alpha minus r cos x sine alpha. And that's just another way of writing the harmonic form here. We should notice that looks similar to the expression that we are told to write in harmonic form. So I can just say let 2 sine x minus 3 cos x equal r, and I'm just going to write the cos alphas first. So cos alpha, I'm just basically swapping the cos alpha and the sine x just so it looks more a bit neater, minus r sine alpha cos x, again swapping the sine alpha and the cos x. And what I need to do now to help me find r and alpha is equate coefficients. So I can see on the left hand side I have sine x, and there's a 2 by it, right? It's 2 times sine x. On the right hand side I have r cos alpha sine x. I'm equating coefficients. So that means that because this is an identity, I want it to be an identity. That means r cos alpha is equal to 2. And the other one, I have minus 3 cos x on the left, and on the right I have minus r sine alpha cos x. So I can say that minus 3, or I can just really just say 3, is equal to r sine alpha. And there we go. Now, because alpha is strictly between 0 and 90, I know that neither sine alpha nor cos alpha are going to be 0. So that means it's safe for me to divide by cos alpha. So I can say r sine alpha over r cos alpha. Well, I'm just basically doing this divided by this. So I have 3 over 2, which is 1.5. The r's will cancel, and that leaves me with sine alpha over cos alpha, which is tan alpha, remember, as 3 over 2. To get alpha on its own, I do tan minus 1 of both sides. Remember, the question wants it in degrees, so I'm going to change my calculator into degree mode. So I have 56.3099, which I'm going to round to 56.310. So let me just show my workings. Arc tan, or tan minus 1 of 3 over 2. That is 56.310 degrees. Great, so that gets me alpha. All that remains now is to get r. And to do that, I'm going to square both of my equations for r. So I'm going to say r squared cos squared alpha is equal to 2 squared, which is 4. R squared sine squared alpha is equal to 9. And I'm going to then add my equations. So I have r squared cos squared alpha plus r squared sine squared alpha is equal to 4 plus 9. I'm going to take out a factor of r squared on the left, giving me r squared cos squared alpha plus sine squared alpha is equal to 13. And then I've got to remember, well, cos squared alpha plus sine squared alpha is 1. So I have r squared times 1 is 13, which just means r squared is 13. To get r on its own, I square root both sides. And I've specified in the question that r needs to be bigger than 0, so we take the positive square root, r is equal to root 13. And I think I'll just leave it as root 13. I think that's a bit neater. Because it doesn't specify it, I'm just going to leave it as root 13. It doesn't say give r to 3 decimal places. I've only done it for alpha because I think it's the nicest way to express it. Okay, so that is our harmonic form. It will be once I've written it in full. So I have 2 sine x minus 3 cos x is equal to root 13 sine x minus 56.310. Being very careful to make sure alpha is in degrees, not radians. So that deals with part A. For part B, we want maximum and minimum values. So for part B, we are given the expression 4 over 2 sine x minus 3 cos x plus 8, which I can rewrite. Okay, I've got 4 over 2 sine x minus 3 cos x plus 8. I know from my answer to A, that is going to be 4 over root 13 sine x, sine of, let me rub that out, make it a bit neater. Root 13 sine of x minus 56.310. That's the 2 sine x minus 3 cos x business. Plus 8 is going to be at its minimum. Now, if we think about any sine function is always bound between 1 and minus 1. It's always between 1 and minus 1. So the smallest that the sine part of the denominator could possibly be is minus 1. So the maximum will occur when we have sine of x minus 56.310 is equal to minus 1. And then that would give us 4 over root 13 times minus 1, which is minus root 13, plus 8. And that would be our maximum. Which is 0.91, 0.910. And the minimum will occur when the denominator is as large as possible. Now that will occur when the sine function is at 1. Which will give us 4 over root 13 plus root 13 times plus 1, which is 4 of root 13 plus 8, and that will be, excuse me, that would be 0.34. 0.345 or 3dp. Okay, so those are our maximum and minimum values. Okay, so be very clear, this is your minimum, 0.345, and the maximum is 0.910. Lastly, we want to solve an equation. So 2 sine x minus 3 cos x is equal to 2. So hopefully, root 13 sine of x minus 56.310 is equal to 2. Okay, that's basically what I want to solve. So to do this, first of all, I'm going to divide both sides by root 13. So I have sine of x minus 56.310 is equal to 2 over root 13. I didn't specify the range in the question, but let's imagine that the range is x is between 0, so x is between 0 and 360. So first of all, I'm going to get the argument of the function on its own by doing inverse sine of both sides. So I have x minus 56.310 is equal to inverse sine of 2 over root 13. I got a nasty feeling that isn't actually going to, no, that will work. Right, so if I do that, making sure that I'm in degrees, shift sine 2 over root 13, I get 33.69. So I have x minus 56.310 is equal to, let's add that on, 56.31. I've just added 56.31 to both sides. I get exactly 90. So I get x, equal to 90. And let's have a look at other solutions we could have. So we want all solutions between 0 and 360 for x. So what I'm actually going to do is let z be sine, no, I'm going to let z be x minus 56.310. So basically, I'm going to have sine z equal to 2 over root 13. So let's have a look at the values of z that we get, and then we can just use the substitution to get x. So I have shift sine, same thing again, shift sine 2 over root 13. $33.69. So that's my value for z. Let me just do a little sketch. That's an awful sine curve. Somewhat better. Okay, 0, 90. So we're solving like 2 over root 13. That's about a half, 0.55, something like that. Yeah, 0.55 roughly. So we're trying to solve. Oh, that's really well drawn as well. Awful. Okay, so there we go. So we know that because we know the range for x is 0 to 360. Now z is just x minus 56.310. So that means to get the range for z, I just need to take away 56.310 from both sides. So that's going to be about 304. About 303.69. So if I find my z values in this range, it'll automatically get me the x values once I transform it. So my first z value is 33.69. Now if I look at the symmetry of the graph, actually from 0 is easier. I've gone to the right from 0 by 33.69. So that means I can go left from 180 by the same amount. So I do 180 take away 33.69. 0.69. To avoid rounding errors, I'm just going to do it exactly. So we have this value, and I'm going to do 180 take away it, giving me 146.310, which is this solution here. So I can say Z is equal to 33.69 or 146.310, because obviously I can't see any solutions further on. So that means either X is going to be, because obviously X is just Z plus 56.310, so either it is 33.69 plus 56.31, which is about 90, so 90.00 we'll say, or X is equal to, and again this is just going to be 180, isn't it? Point plus no, that's not going to be 180. No. Yeah, 202.62. And we can check our solutions, obviously degrees. And we can check our solutions. So if I look at the original equation, it was 2 sine x minus 3 cos x is 2. Let's try it. 2 sine that minus 3 cos that. We do it, we get 2 to one significant figure, certainly. And if I try the other one, obviously if you try 90 in there, you get 2 take away 0, which is 2. So that basically works. So hopefully that explains how to do this more difficult trigonometry question on harmonic form. And I'll send you some similar solutions, send you some similar questions to have a go at on your own.